Yeah, hello. As Luca said, I was working many years in industrial automation, like making all these factories up and running with control systems. And then 2017 around, yeah, when the first ransomware hit industrial sites, maybe you know the German train system got like with ransomware infected. I got changed into security with my employer at that time, and now since 2019 I work for Switch. Switch is running the national education network in Switzerland, but also for the web space.ch.li we are doing the registry. And the small team is looking after critical infrastructure in Switzerland, mainly the power, but also like train or post or airports. So what I want to show you today is like kind of the learnings we made when we started to monitor these industrial networks, because it's a bit different than normal networks you might know. So first, in industrial control you all the time have the physical aspect. It's not just like virtual or digital, so you have something, you measure the temperature, for example, like in here it's too hot, then the aircon is running faster, that the temperature is getting down. So that is how it works. And then of course for flows or full pickup, this you already know. I don't have to go in details for that. Also in the industrial world for many years the networks, they were separated to, let's say, the IT or the internet, but now with Industry 4.0 or smart industry or whatever you take, sensors get directly connected to the internet. But these sensors, they are not made for that, or these control systems are not made for it. So that's why monitoring is very important. So now this is the biggest change, the biggest difference, for industrial protocols, because mainly these protocols were just ported or like copied from the serial communication into TCP/IP. Means the payload is still the same like it was 30 years ago with serial communication, as you might know. And of course everything clear text, nothing encrypted, no verification, so for monitoring is still easy. And also what is different, the flows normally go over days or even weeks. So you have for one connection just one flow which is running forever. And every packet in this flow is important because one packet can contain the information, what the system is doing or not. So of course attackers are using this information, we will see later on. Yeah, just overview, I go a bit fast because this short overview in the industrial space, there's not many malware present, like up to before April this year we had 5 big malware groups. And this year, with unfortunately the war in Ukraine, Industry 2 came up, and another one, Type 3, is not seen in real life. It's just they catch it in the US if you want to see it. So the bad guys, cyber criminals, they are also starting to understand how industrial systems work. And they use this information to try to interrupt, disrupt, or make any malfunction of the system through cyber attacks. So when we start monitoring in industrial networks, maybe you know also from IT networks, when you start monitoring you will see a lot of configuration issues, like timestamp not correct, wrong ports used. Many things which have to be corrected before you actually can start with the monitoring. And another big issue in these networks are policy. Like if you have a policy in your company, don't use TeamViewer. is very hard to enforce because many people still use TeamViewer because it's just easy and it works. But if you are the network engineer, then it's very hard to keep control over your network. So the monitoring also helps in these cases. And luckily, just in rare cases, we see like cyber attacks, if you want to say, or security-related problems. Also, I want to mention this monitoring is all the time you see when something happened already. So we call it mitigation control. It's not something to prevent that something happened. Because we are passively listening to the network flow, so means if a packet passes through our monitoring with the bad content, then the bad content will reach the destination and let's say the explosion will happen. So you have to put that a bit in context in industrial systems. It does not help as much as it might help in the IT side where you have more time to figure out what is going on. Okay, so just there are many commercial products, but they not only do network monitoring, they do many things, many other things. So we realize that lots of organizations, they are overwhelmed with this type of products because they simply have a too broad range of functionalities. So we started to look at open source network monitoring tools, and that was 2.5 years ago, where I made like a little research, and I saw that with ntopConf, it is supporting my IEC 104 industrial protocol, and it is supporting a kind of script language that with Lua I can add some own logic to the monitoring system. Exactly. So where to start when you want to start monitoring OT networks, then ntopConf can help you very much because it is all in one place. If you compare with C, for example, you have the rules and then you still need maybe a user interface. It's a bit difficult, especially in the industrial world where engineers are not at all familiar with network. They know what is an IP address, but not much more. So easy user interface, like we have now with predefined alarms in ntopConf, is really helping, or the risk score is also helping because it helps you to understand what is going on and decide if something is bad or not. But the most important what is you need to know what you want to look for. So just start to monitor it and you will get lost in your network. So in the industrial world we often start with the remote access. As I said before, is kind of a mess in most of networks. So remote access, TeamViewer, any other protocol, VPN, whatever, and nobody knows who is in the network and is doing what. Of course, they are all kind of trusted system integrators, but as nowadays such a system integrator can get ransomware as well, you don't have to control anymore what is going on or like who is like entering in your network. So that would be the use case. We checked what is going on in remote monitoring, and we define then the playbook that you say what you do when you detect TeamViewer, for example. Do you have to run Saturday night, or can you wait until next Monday when you're back in the office? There are lots of online resources for use cases, what you need to look for. Many of them, or almost all, are integrated in ntopConf. So you can really start monitor industrial networks with ntopConf. Placing the sensor, this is something we are discussing because in industrial networks it's a lot of distributed. Yes, you have many distributed locations. And to get from every location, like to RSPAN, for example, all the traffic to the central station is difficult, or it needs maintenance as well. So this is kind of, we are currently in discussion for how to address the distributed setup of this type of network. Best practice, monitoring often is seen as a project, like you assign a project manager some time from the people who implement it and then it's finished. But it's not like that. If you start monitoring, it is a never-ending project. You all the time need somebody who look after the alerts, who is looking after how these alerts can be maybe fixed, or if it's really something they have to figure out what is going on. So it's never finished, and this is very much underestimated. So with regular meetings we put in place, it helps that people get used to it, and so you have maybe every 2 weeks a meeting, you look at the alerts and you see, okay, now these 10 alerts we go through, we check if good or not good, and so you work through all the alerts. Some examples from what we see, the service map Matteo showed. I think it's an older version, but yes, of course, very helpful for us because we see who is talking to whom for first analysis of the network. Then often in industrial world, the geofence is seen as something as a security measure which you can trust. With the monitoring, we often can prove that this is not the case. It depends which supplier or which database you use, so it can be correct or not. So that is one example. Then the industrial protocol, like I mentioned before, maybe here's some more information. So this industrial protocol is using the TCP link for like its own communication packets. The problem is in one TCP packet you can have many of these let's say IEC 104 packets. So with signature-based approach you will never catch all this information because you really need to look through the payload to analyze like what is inside these packets. So if you take Suricata or ZIG, they cannot do that because they are signature based, so they cannot really go through the payload. So that was lucky that we, like I said, with the Lua script we could implement it, but now it's fully implemented in ntopConf. So you see below the example with the flow in the info field, you have some additional information which the OT engineers or the industrial engineers, they will understand. It helps them to classify to what the flow is or what is going on in the flow. And looking at the recent malware from Ukraine, we figured out that they use many commands in a very short time, which in normal operation is not the case. So we can look, the blue picture there, we look at the transition from measurement to commands, and when we see too many commands in a short time, we trigger an alert. So this is with Luca and the team, it's very nice because we can very fast adapt to what is going on in the real world or what the cyber criminals are developing to attack critical infrastructure. And this protocol, the IC104, is very common. I would say in Europe, in every energy distribution facility, you will find this protocol. Then, of course, clear-text passwords also very common in these networks, and this is normally. It's not that we don't know or that we can do something about, but it's really helpful when you talk with management to make them understand what is maybe a problem or that the network needs better protection. If you can show them, hey, we can see the password which is going through the wire, and they look with big eyes and then they understand, oh, we have to do something about it. And of course, you can also take malware examples and do online you find many PCAPs with malware. You can download it and run against ntopNG, and you will see how it starts to blink and like what is going on in the malware, like the binary application transfer here we see, or the TLS certificate, which can be a problem. Looks like a lot of work, yes it is, but nevertheless, with the nice thing with ntopNG is the product itself uses very low resources, so you don't need a huge server to run on it. And if you can tap somewhere into your network, you really get visibility very, very fast. That's it. Thank you.